Hi everyone, my name is Rohan Singh Poona and welcome back to my channel. This is a bonus video and in this video we'll be looking into how to select algorithms based on time complexity. So let's get started. So when you code algorithms or solve problems on various coding platforms like HackerRank, LeetCode, CodeChef, CodeForces and so on, there is always certain constraints given to you for the problem. For example, we we might have a constraint saying that n lies between 1 to 10 to the power 8. Now these constraints actually depends on more or less the platform that you are coding on, or it actually depends on the mostly on the platform that you're coding at. So now based on these constraints, you are actually required to write a code or an algorithm which runs under 1 second for the given inputs. Now, if your algorithm exceeds this 1 second, if your algorithm exceeds 1 second, and then you might get an error saying TLE, which is nothing but time limit exceeded. Similarly, you also have a memory limit. And usually on these platforms, the memory limit is roughly 256 MB. And if you exceed this memory, then you might get an error saying MLE, which is nothing but memory limit exceeded. Memory limit exceeded. Or you might also see something called as segmentation fault. Now let's try to analyze these constraints which are given to you, and based on that we will see further how the time complexity will vary. Let's say now usually what happens is around approximately 4 into 10 to the power 8 operations on these online judge takes 1 second. So if your algorithm does 4 into 10 to the power 8 operations, it will ideally take roughly 1 second on these platforms where you will code. So let's take an example and try to analyze this further. Let's say the given constraint to us is nothing but n lying between again 1 to 10 to the power 8, and let's say we write a code snippet which is something like for int I equals to 0, I less than n, and I plus plus. Then, and let's say we are also performing some operations, operation 1, operation 2, and that's it. So as we know that this condition will run nearly n times, and this increment will also happen almost n times, actually n plus 1 time, but let's round it off to n. Therefore this will be 2n operations, and let's assume that this operation 1 and operation 2 takes 1 unit of time. Therefore this will take 1 unit of time, this will take 1 unit of time, and they are going to run n times, therefore 2n operations in total. So approximately the total number of operations that will be performed by this code snippet is going to be 4n operations. Now if we try to substitute the value of n, the max value of n, which is going to be 10 to the power 8 here, then ideally our code will perform 4 into 10 to the power 8 operation when n is the largest, or when n has the maximum value, which is 10 power 8, and this code will run approximately in 1 second and will be accepted on those platforms. Now considering that 4 into 10 to the power 8 operation takes 1 second, let's analyze some more constraints and see what is the maximum time complexity that we can have for our algorithm to run that code under 1 second. So now we'll consider, as it's mentioned, 4 into 10 to the power 8 operation takes 1 second, and let's analyze some constraints. So now, as you can see, if the value of n is 10 to the power 8, then a big O of n approach will obviously not work, because that will be 10 to the power 18 operations, right? Therefore, the time complexity of the algorithm, which can run under 1 second, for a constraint where n is at max 10 to the power 18 is gonna be big O of log n. Similarly, if n is 10 to the power 8, then we can have a time complexity of big O of n, which will be running under 1 second, and it will be accepted. And any algorithm which runs better than big O of n, or runs, let's say it takes less time than big O of n, will also be accepted. So now let's jump on to, let's say, 10 to the power 7. If n is 10 to the power 7, then the time complexity that can be accepted is gonna be big O of n log n. Similarly, for 10 to the power 4, it's gonna be n square, as 10 to the power 4 into 10 to the power 4 will be 10 to the power 8, and it will be accepted in 1 second. Now coming on to if n is 5 into 10 square, so it will be having a time complexity which can be accepted as big O of n cube. Similarly, if n is having a range of 0 to 90, the big O of n to the power 4 algorithm will also be accepted under 1 second. Similarly, if n ranges between 0 to 20, then the worst case complexity for an algorithm that can run under 1 second with this constraint is gonna be big O of 2 power n, because 2 power 20 is approximately 10 to the power 8 operations. Now, the last constraint that you can see, let's say if n ranges between 0 to 11, then big O of n factorial approach can also be accepted under 1 second, as 11 factorial is nothing but nearly 10 to the power 8. Hence, it will run under 1 second. Now, as you can see the time complexity here, now starting with big O of log n, big O of n, n log n, this is in the order of increasing growth, or you can say increasing order of growth. Now, big O of log n is gonna be less than big O of n, big O of n is gonna be less than big O of n log n, and so on. So having a fair understanding of the time complexities and the constraints will always be helpful to you. And actually, for example, let's say you are a competitive coder, or you are getting started with competitive programming, then if you analyze the constraint, then it can actually help you in deciding algorithms, real quick. For example, if you have a constraint given as 10 to the power 7, then obviously you know that a big O of n square approach will not be submitted on that platform. Hence, you will try to think, a better approach. And as you know, if the constraint is 10 to the power 7, we know that the time complexity that can be, accepted is gonna be big O of n log n. Therefore, we can also, try this hack, by thinking in a reverse manner that what algorithms are actually, gonna take big O of n log n time. And we know it might be sorting, a sorting algorithm, the best sorting algorithm might take big O of n log n time, and our thinking might go, towards that, and that can act as a hint. So analyzing these time constraints, or these constraints given to you, will be very helpful when you are coding on certain platforms. So I hope you find this video very helpful. If you are someone who is getting started with coding on these platforms, this is going to be really useful. If you are going to start with competitive coding, again, this is very important. And that's pretty much, guys, in this video. And thank you for watching.